Everyone, so in this video we are going to look at the basic Atwoods machine. We are going to look at the basic concept of Atwoods machine. So Atwoods machine basically is a simple pulley block system. It is a simple pulley block system. In this, we discuss an ideal pulley which is massless and has negligible mass and rotates on its axle without any friction. So we talk about a frictionless pulley, frictionless as well as massless pulley. In most of the questions this is only the case. In very less questions in JEE or NEET, we are going to find where the pulley is also given some mass, and in some standard books there are questions where there is mass in the pulley. Okay, so let's see the basic system. So this is the basic system of masses. Okay, so let's say if this is the pulley, let's say that there is tension T in the string. We know that if there is mass which is on one side of the string, then the tension will always be running from the object. Okay, just like here is the pulley, so the tension will be in this side, and so like this. Okay, so this is how it is seen. Let's say if the mass of this block is m1 and that of this is m2, so we can also frame equations regarding these pulley block system. So the equations, how do we frame them? First we draw the FPD of the masses. Let's say m1 has a greater mass than m2, or whatever may be the condition, so that acceleration is like this. Okay, so we can frame the equation simply. So equations are like this. Okay, first we have to draw FPD. So that is the force body diagram of this. So if we see for mass m1, the tension T is upwards. Mass m1 has a weight which is acting downwards, and since you can see there is an acceleration, so A. For m2, the same type of case for m2, tension T. Since there is the same string, tension will be the same for both the blocks m1 and m2. So T, mass that is m2g, and acceleration that is A. So let's see. So we can see now in the first case, that is of mass m1, we can see that m1g is acting downwards and tension is acting upwards, and the net acceleration is downwards. This means that m1g is greater than T. This means the force exerted by m1g minus the force exerted by the tension is equal to the net force exerted. So we can write like this. There is no force in the horizontal direction, we can see. So we can say m1g minus t is equal to m1a. Next equation we can frame for the second case of m2. We can see m2g is acting downwards and tension is acting upwards. Oh, really sorry. I'm really sorry. This acceleration is upwards. Really sorry. So this acceleration is upwards. So m2g is acting downwards and tension is acting upwards. If tension is acting upwards, can I say tension is the only force upwards, right? And m2g is less than tension. Can I say that? Because the net acceleration is towards upper side. This means that the net force will be on the upper side. So that means T minus m2g is equal to m2a. Let's say this is equation. Okay, I'll write it nicely. So our equations are m1g minus t is equal to m1a and t minus m2g is equal to m2a, right? So if this is 1 and this is 2, on adding equations 1 and 2, we can get, if we add these, then minus t and plus t, they will get cancelled. So the things that are left would be m1g and m2g. m1g minus m2g. So g m1 minus m2 is equal to, can I say if we add them, a will be common, m1 plus m2, simple mathematics. Therefore acceleration is g m1 minus m2 upon m1 plus m2. Okay, so this is our acceleration. Okay, now this, we have found the acceleration. Can we find the tension as well? Yes, we can find the tension as well. So we can get it from our first equation, that was m1g minus t is equal to m1a. If we substitute acceleration here, m1 into a, that is g m1 plus m2 m1 minus m2 upon m1 plus m2. Therefore T is m1g minus m1g m1 minus m2 upon m1 plus m2. Okay, so this is m1 plus m2 m1 plus m2 multiplied by m1g minus m1g m1 minus m2. So this is equal to if we take m1g common, then we get m1 plus m2 minus m1 minus of minus m2, that is plus m2, divided by m1 plus m2. So this is equal to m1g. If we see, then m1 and m1 get cancelled, so that is g m1, and this is 2m2, so this is 2 m1 m2 g upon m1 plus m2, right? So this is our final tension. Okay, so this is our final tension, right? We have another system of blocks as well. We can also see that. So this is for part 1, the basic Atwoods machine. This is the part 1 video of this lecture. I hope you liked it, and please share it to more and more of your friends. Thank you so much for watching. Bye. We will soon get part 2, in which we will see the another system. Bye.